Hi all, my name is Naumita, doing research at College of Engineering Trivandrum, affiliated to APJ Abdul Kalam Technological University, Thiruvananthapuram, India. And my work is Paraconsistent Feature Analysis for the Competency Evaluation of Voice Impersonation. And the paper is authored by Rajiv Rajan, Naumita A and Sri Lakshmi S. This is the overview of our work. Mimicry is the act of imitating or copying the behavior, appearance, or characteristics of someone or something else. It can involve replicating various aspects, such as speech, gestures, or sounds, to closely resemble the target being mimicked. Mimicry is commonly seen in nature among animals, but it is also a popular form of entertainment in the human world where individuals, known as impersonators or mimics, replicate the voice of or mannerisms of public figures or famous personalities. Mimicry can be used for deceptive purposes, such as in voice-based crimes, where perpetrators try to disguise their identity by mimicking another person's voice. During voice impersonation, a voice imitator modifies the position of articulators like lips, tongue, speech duration, and pitch to replicate another person's voice. A competent imitator, capable of mimicking the target voice with maximum similarity, skillfully controls the articulators to achieve a closer voice match. We investigate the efficacy of feature sets to identify the best voice mimicking candidate using paraconsistent feature engineering. Selecting features carefully is crucial for achieving accurate classification. Paraconsistent logic provides valuable insights into the problem of feature quality by using a non-classical logical system that can effectively handle conflicting situations. When classic logic fails to address these issues related to inconsistency or uncertainty in pattern recognition tasks, researchers rely on paraconsistent logic. Paraconsistent feature engineering. Paraconsistent analysis of spectral and prosody features to rank them based on their efficacy in voice mimicking is performed in our proposed task. We have used a recently proposed technique of paraconsistent feature engineering. PFE helps to picture the mimic target similarities and the mimic non-target distinctions exhibited by these features in the paraconsistent plane. Feature ranking method is proved suitable in reply attack detection and speaker verification. Figure shows the proposed framework for PFE analysis. Figure A shows the outline of the PFE for the proposed task. Figure B shows the steps of data point computation in the paraconsistent plane P equal to G1, G2 for case 1. Similarly, we calculated the points for case 2 up to case 5, and finally the centroid of these data points are calculated and marked in the paraconsistent plane. Target similarities and the non-target dissimilarities are calculated and obtained alpha and beta values corresponding to the target similarities and non-target dissimilarities of case 1, and using this alpha and beta value the data point P1 is calculated. The PFE approach is as follows. All the available X number of feature vectors are normalized using the min-max scalar. Target similarities are analyzed using alpha, which is the level of faith. The non-target dissimilarities are analyzed using beta, the level of discredit. The degree of certainty G1 equal to alpha minus beta, and the degree of contradiction G2 equal to alpha plus beta minus 1 are the points in the paraconsistent plane. The paraconsistent plane represents the efficacy of the feature sets. So, for the case 1, the calculation step is as follows. For the case 1, the celebrity 1 plus top artist from Moss test is considered as one class, and the feature vectors obtained from the audio files of the other targeted celebrities, celebrity 2 to celebrity 5, is also taken. And from that we define A, that is maximum minus minimum within each class for each feature vector. And SVN is equal to 1 minus A, indicate the similarity within the target. Therefore, SVN equal to 0 represents low target similarity while SVN equal to 1 represents high target similarity. Y bar Cn is obtained by taking the mean of the similarity vector SVN. And this process is repeated for other targets from celebrity 2 to celebrity 5 to compute their respective Y bar Cns. And finally, in order to calculate the target similarities, we compute alpha value. Alpha 1 equal to minimum of these Y bar Cns, where Cn represents the target n and SVN represents the similarity vector corresponding to target n. Non-target dissimilarity is analyzed using range vectors, that is the degree of overlaps. Minimizing the overlap is essential. So, beta 1 equal to O by F, where F is the maximum number of overlap. F is equal to n into n minus 1 into x into z. Here n is equal to 5 since we are taken into account 5 celebrities. Z is the dimension of the feature vector and the alpha value greater than or equal to 0 and beta value is less than or equal to 1. So the final G1, G2 is calculated using this equation and the value of G1 and G2 is in between minus 1 and plus 1. And for case 1, we calculated the data point P1 equal to G1, G2. And similarly, for the case 1, we computed P2, P3, etc. up to P5. And centroid of this, all the points are calculated. And ideal cases linearly separable features, which gives 1, 0 value. Distance between the point P equal to G1, G2 to the ideal point 1, 0 is calculated, and the best feature set has a point closer to 1, 0 point as per PFE, and here the spectral features are more closer to the 1, 0 point. The results using PFE ranking, the alpha, beta for 5 celebrities and mimicking artists is shown in the table. The dataset used in this study is from a paper of Lena Mary et al., which is mentioned here. In that dataset, we have 20 celebrities who were mimicked by 5 professional artists in the Malayalam language spoken in the southern part of India. Artists were free to speak any text of their choice while mimicking the celebrities. And the recordings are of sampling rate 44.1 kHz, 16-bit resolution, were made in a studio environment. Celebrity speeches were collected from the environmental programs and the musical shows. Features are computed frame-wise for analysis using Librosa. Spectral features are MFCC, chroma, MEL, spectral contrast and tonets. Prosodic features used are pitch, speaking rate, loudness, intonation and tempo. And the classifiers are implemented using Python Keras TensorFlow framework. And the classifiers are used for as models for ranking the best artist based on the similarity to the target voice in our experiment. So we have used machine learning classifiers like multi-class SVM, random forest, deep learning classifiers like DNN and LSTM. The classifier architecture for SVM and the parameter setting which is used in the experiment is also given in the table, and LSTM architecture is given in the table. For random forest, we have selected a number of trees in the range 10 to 100 and maximum depth of each decision tree is set to 10. Entropy is chosen as a criterion function to measure the quality of each split in the decision tree. And our DNN has 2 hidden layers with 64 and 128 nodes with a ReLU activation for hidden layer and sigmoid activation for the output layer. A subjective evaluation test was conducted with 20 listeners to identify the best voice imitator who imitated the voice of the target or celebrity with almost similarity. The audio files of the target or celebrity and the imitators artist were played for the evaluators. They were then asked to grade the performance of each artist on a scale of highly dissimilar 1 to highly similar 5. These scores were converted to numerical scores, and the mean opinion score was calculated by averaging the values reported by all the 20 evaluators. The artist with the highest score was identified as the best at mimicking the celebrity. We expect the trained model to output the same candidate as a top-ranked artist. Moving on to results using DNN classifier. Here, this bar plot shows the scores obtained for all artists in mimicking 20 celebrities using the spectral or prosody DNN framework. For each celebrity, the first bar shows the spectral DNN, The second bar shows a prosody DNA. The number in the circle shows a label of the best artist from the mostest. Results of feature important calculation is shown in this figure. The results of DNN model is shown in figure with mean opinion score. The rank 1 position is highlighted in red. ART stands for voice mimicking artist. For celebrity 1, artist 5 is showing best performance for mostest spectral DNN framework, and artist 1 is showing the best performance using prosody framework. So when comparing this, we can say that spectral DNN framework is showing the best performance when compared to prosody framework. In the case of celebrity 2 also, we can say that the mostest is showing that artist 3 is the best mimicking artist, and the spectral DNN framework is showing that artist 3 is the best mimicking artist. But the prosody is showing that artist 1 is the best mimicking artist. So when we consider the celebrity 3 case also, it is showing. So result for all the celebrities, our targets are provided in the supplementary material. And the results using different classifiers, accuracy in top X hit rate is shown in this table. Moving on to the summary, this study is first of its kind in statistically analyzing the efficacy of acoustic features for voice impersonation. The adopted technique of PFE analysis reported spectral features as best helpful in finding the best voice mimicking candidate from a set of candidates, supported by the classification accuracies obtained from our 4 machine learning or deep learning classifiers. The relevance of the study is analysis proved helpful in demonstrating the efficacy of the different available features under stringent data conditions. The ranking of the features would help implement simple predictors without the problem of overfitting to aid speech or audio classification tasks. Moving on to the conclusion, the Paraconsistent framework was chosen to draw inferences about the performance of spectral or prosody features to identify the best imitator. In this study, we trained SVM, random forest, DNN and LSTM using feature sets calculated from the target voices of 20 celebrities. We then tested these classifiers with mimicry voices produced by professional artists. The best performing DNN approach with spectral features reported a top 2 hit rate of 0.90. These experiment results demonstrate the potential of PFE in selecting the optimal feature set for any audio classification task under data stringent conditions. These are the references. Thank you.